So we'll wait for 5 minutes more, right? Or
Hello, a very good morning to all of you.
good morning, madam.
My name is Anjali Kumari, and I'm one of the student coordinator of this national webinar. So today is the second day of national webinar on geospatial technology. And hope you all enjoyed yesterday's session and take away a lot of information from Dr. Gouri Sankar sir. And I'm fully sure today's session will also going to be very informative. So let me introduce sir. Dr. Gouri Sankar sir presently is a scientist and GIS expert. So I think that so you can continue your session for today.
Okay, thank you, madam. Thank you, Anjali Kumar, madam. And good morning, all of you. Anyway, today now I'm going to start my presentation on digital image processing. Are you able to see my screen?
Yes, sir, it's visible.
Okay, thank you.
Yes, sir.
Thanks again for your participation and give me an opportunity to share my knowledge with you guys. And thank you for the BNJ and Anjali madam for encouraging you and organizing this Geospatial technologies information system. Thank you guys. So today we'll discuss about digital image processing. As in my previous lecture, we have collected the remote sensing data. So these remote sensing data, once you are after acquisition, we need to extract this information from this data while different types of processing techniques are available. So that as per our purpose or the scope of study, we'll be able to attain the information from the remote sensing data. So in there is a one data, but its application or its usefulness is different. So we have to decide that what exactly we need as per our purpose of study. Simultaneously, what are the principle or what type of data we need to choose for collecting this information. So in today's content, we'll discuss about what are the different types of data acquisition technique for the image processing. And as we have discussed earlier session, that there are some different types of image, like sometimes we have seen panchromatic image, we have seen that there's some multispectral image, some hyperspectral image. So what is the useful of this image, and what is the how do we process this image to get the information or extract the information from the data? That we will discuss today. And secondly, we'll discuss about the different band combinations. Like sometimes we are not able to get the information by not only by just from the multispectral image, but we need to define the spectral band. So, for example, we would like to extract the information about the thermal properties. So at that time, we need to consider about the thermal band. So when we'll use this thermal band, then what is the composition of this band? So that we will discuss today. And then sometimes, as I talked earlier, that there are some error will come because there are atmospheric layers are there, as well as in our Earth surface there is a lot of composition, lot of mix variables are there. Like there is a vegetation, there is a water bodies, there is a buildings, roads, several natural and artificial features are there. So as we know, the each features of our object or the each object of our Earth surface having some different spectral properties. So once and our sensor or the satellite that is mounted at approximately for the sun synchronous it's 700 to 800 kilometers above the Earth surface, and for the geostationary it is approximately 36,000 kilometers from the Earth surface. So this much distance, when it's travel, definitely it will carry some error, or there is some mixed information system. So how will reduce this information? How will reduce this error? To get the exact information and the real information about the Earth surface and how much accurate it will be. So that will be studied through our image enhancement technique. And the last, I will discuss about the rectification. So in rectification, what we will study that uh, once we have the information, or sometimes we can get the information or the satellite or the means remote sensing sensor. Those who are collecting the information which is not exactly matched to our real world coordinates, or there is no any projection system. They'll just take a picture, high quality of picture. So after getting this picture, we need to project it, or we need to match it with the real world system, or the our real world coordinate system. We need to provide the coordinate, that latitude, longitude, to find out the exact locations and where these changes, or where the objects are located on our Earth surface. That we will study up through the rectification technique. So overall, there are 5 sections. So we'll start one by one. So before that, just give you some brief introduction about the image processing, digital image processing. Uh, you can see sometimes since for a better example, like medical science or some hospitals or nursing home, when there is some fracture in our body, so we'll do some X-ray, and this is also a part of the image processing. So because by processing, we just get the information about the interior part, where is the fracture, and how is it? Is there any problem or not? Or the doctor, before doing any operation or surgery, they will analyze this image, and based on that, they will plan or make the surgery. So in our computer technology, what we'll do after getting the informations, uh, the signals or the electromagnetic radiation that is collected by the remote sensing sensor. So for example, we have seen in our resolution technology, the resolution, that image remote sensing sensor has the capability of discriminate the gray levels for in case of 8-bit of data, that is 0 to 256, means one color can be divided into 256 times, right? And in case of the spectral resolution, what we have seen, we are just able to visualize our natural bands, like visible spectral range, which is ranging from 0.4 to 0.7 micrometer region. But after that, means when we are considering about the microwave remote sensing data, when we will consider about the thermal remote sensing data or the infrared data, that is not visible, or we cannot able to identify for eye, or human cannot be visualize this system. But computer technology having the capability through different types of techniques and process to identify these features and to enhance these features to extract the information from the remote sensing data, to evaluate the sensor, like there are some different types of errors. It may be the geometric error, it may be the radiometric error. Geometric error, that means the error that is occurred due to the locational position, that is like coordinate position, or some of the means geometry of the satellites, like its functional characteristics, and the differentiation of the orbital plane, differentiation of the sun angles. All these factors are responsible for creating these errors. Sometimes bad weather conditions, which is also creating error. So image processing, through image processing, there is a possibility to remove this error and to get the exact information of the features. As such, image processing also help to evaluate the image statistically. So, for example, we can calculate the length of the linear features. It may be the roads, it may be the drainage or sewerage, whatever it is. And as well as aerial calculation can also be possible, so that we can accumulate all these informations, and based on that we have to make a plan, or we'll just do forward these informations for the planner to take the correct information or accurate measurement of the technique. In case of the engineering characteristics perspective, we can say, there is a much more accurate measurement required for the planning or decision making. So in that case, remote sensing technique is very much useful to identify the exact information or estimations of the accurate area or length of the features, and then to access or improve the quality. Sometimes what will happen for the conventional survey or the field survey, we may not access or getting the exact information, or we are unable to characterize the features as per the physical or the chemical properties. But there is a possibility of image processing technique to analyze this remote sensing data and the associated features to more accurate informations and in detailed information or real-time information system, so that it will improve the quality of our product, or improve the increasing the means capability of our work, as well as means the good product will be delivered to the stakeholder or the clients as per their requirement. And lastly, not last, we can say this is a in geospatial technology. When you are talking about GIS, remote sensing, and all these things, so in remote sensing GIS technology, always we tell that where the remote sensing is aimed, GIS is start from there, because the remote sensing, image processing, all these things, we are getting the information only. But what GIS will do, that we'll discuss tomorrow on our next lecture, that it will gather all this information. So this is one of the major source of information where the GIS is used for the planning or decision making or different types of modeling work. So another information that I need to discuss, that already you have seen the image yesterday. I've already discussed. But one thing that you need to keep in mind, that the image you can see also in your mobile phone, or you have to just take a picture. Once you make it zoom in, so that you may get the number of pixels, right? There is a square box. So this square box is called basically a pixel. That is you can directly, you can commonly say that people like picture elements. So in remote sensing sensor, having the capability to get this picture element at very large scale and very finer resolution, along with their spectral properties, so that we're able to identify these uh, features what are available in the earth surface by discriminating these picture elements. So pixel is the smallest unit of the digital image, and this is providing the brightness of the image, as well as this brightness will come based on its spectral value, like electronic radiations that is recorded, and based on these characteristics we are able to classify the which features are what are the features are available on our earth surface, as well as its position. So I have taken an example that John R. Jensen, who has published a book on the digital image processing in 2007, and he has given example like remote sensing process. You can see that in my previous lecture, I have already covered the statement of the problem, like what is the means, why we are using this remote sensing data, what is the usefulness, and when we need to consider what type of data, and different types of data collection procedure, that platform, sensor, and means where camera system, like types of image, or like active remote sensing, passive remote sensing, all these things. So once completing this process, now your digital image processing technique or digital image process will start. So in digital image process, why it is required that because this will give us the means we can accumulate the informations in the computer. Like previously, you can have that our government or the developing country or developed country, people are trying to, like now we are just communicating. Previously, the class only taken by the means on ground, but we are now taking class through means conferencing systems or the online system, or we are trying to accumulate the information digitally. We stored the information. Previously, we stored the information in CD drive or others, and now we are using hard drives, pen drives, etc. And there is a because the hard copy or the visual analog image, which is very difficult to collect, or sometimes there is a possibility of damage after a certain time of period. But in digital image, we can record it, we can store it. Now server is available, so people can store a lot of information. Hundred of years, thousands of years. So even we can transfer this information from one place to another places very easily, which is not possible for the analog data or visual data. Therefore, in digital image processing is very much important in that case. And simultaneously, there are a lot of computer algorithms developing day by day. So using this computer algorithm or applications, we are able to extract the different types of information, and we can use the number of processing techniques to get this information, which is not possible through the analog image. So in digital image processing, there are a number of aspects are there. However, in today's class, we'll consider only 3-4 aspects. Like one is the how means color image is generated, or what are the color applications of this color image, what are the advantages and disadvantages when we will use this type of color image. This technique will discuss, and we'll discuss one, the image enhancement technique, which is another important characteristics of the image processing, and the rectification technique, which is need to define the coordinate of the means projection system. However, there are another also techniques as available like classifications, and different types of change detection, modeling, geo visualization of the data, some accuracy assessment, some ortho rectification, photogrammetry. So there are a number of image processing techniques are available. However, which is not possible in a single class, you can say. So we'll just consider only the four major aspects, which is the preliminary part of the image processing technique that you need to understand, and we should consider whenever we will try to analyze this remote sensing data for the processing. So first, we'll discuss about the data acquisition technique. There are when we are just considering a project or plan for work for the remote sensing or the geospatial technology related aspects. So approximately 70 to 80% cost will consider for the data acquisition or the data gathering system, because it's somewhat costly. Because another important advantage of this technique is that although it is costly for a time only or a single time, but once we're getting the information, we can use it for a last 10 to 20 years. And once the information should be extracted, you can use for the end of the life or the entire period of the system. Because once you're getting the information, it cannot be changed because our Earth surface is dynamic, right? So we can classify the data, or we can identify the historical changes or chronological sequential pattern of variations of the changes of the Earth surface features, and or the measurement, how it is. So, for example, if you are going to develop or constructed dams or reservoir, so what you do before that, you need to identify what is the river path, how it is changing yearly, or 5 years interval. Where is the minimum widths are there, so that the project cost can be reduced. So all these things means a lot of information you can gather from this information, from this image or from this image processing. So in that case, you no need to accumulate the information separately, or sometimes through conventional survey. You cannot possible that is right now. If you are in 2021, if you need the information of 1990 or 2000 or 2010, what are the exact situations of this river path or river width of this particular area, you cannot get this information through conventional survey or field survey, because you cannot go back to this situation. Therefore, what we will do is just collect this information and gather this information to get or to measure the length or area, or store all this information. So this data acquisition technique. So there are different types of data acquisition technique, like satellite image. Already we have discussed yesterday. Like we have used sun synchronous data, because for the geospatial data that we have already discussed, only used for the communication purpose, as well as different types of broadcasting systems and the network and signals. But in the sun synchronous data, all the resources or whatever the features are available, so that can be analyzed, or that can be classified by this satellite image. And then aerial photographs, which is again the platforms related issues that will use the aerial aeroplanes or the drones data. So we just fit the camera with the airplane and drone, and collect the information at very high resolutions. And then there are some aerial laser scanning. Sometimes laser data, or you may have heard about the LiDAR. So there are different types of technique, like light detection and ranging, and there is terrestrial radar, there is space shuttle radar. So all this LiDAR technique or laser technique is used to collect the remote sensor data for the image processing or getting the information more accurately. And simultaneously, if, we have seen that there is a ground-based platform, like already whenever we are going to do some cadastral mapping or cadastral survey. or as the engineering perspective, you may definitely have carried out the survey about the GPS or BGPS, as well as the total station survey. So all these are the techniques or acquisition process to collect the remote sensing data. Because why we are going to use this means GPS or BGPS survey? GPS is another section of the geospatial technology that I just give us some brief description. Our we may discuss later also in another seminar or like that. So in GPS, we'll just get the information about the latitude, longitude, like geographic location, as well as the elevations of the Earth surface features. So why it is required? Because as we told you earlier, like whatever the image or satellite data we have received from the sensor or satellite, that have, there is no any coordinate system or projection system. So what GPS will do, it will provide us the geographic coordinates, exact locations of the Earth surface features. So based on that, we'll just put these informations into the satellite data and getting the means real world features, and we can means compare it with the real world features to get the exact locations of the Earth surface features in space. And simultaneously, there are different types of maps and means photos are available. So what we'll do, we'll just different means convert it into the digital part, and then compare with our digital image or the information that is collected from the different types of platform, like it may be the ground based or air based or the space based platform, and update this information or validate this information. So, for example, sometimes topographic map that there are a lot of topographic. You may use this topographic data in your study or in your project work. So these topographic maps are not in digital format. Now, Survey of India is trying to convert to digital format. Right. So this is the technique, that acquisition of the information. Why they are doing this? Because they can easily compare this information, or they can validate this information with the current situation or the current changes of this Earth surface features. So there are some basic examples that methods and what are the advantages, or how what are the accuracies and cost that I've already collected from a research paper. And you can see that mostly in your engineering purpose, you have to use the photogrammetric technique and defensible ground survey or some of the image processing purpose. Whereas in photogrammetry, we need that some project cost is cumulatively high, but its accuracy is much more, and we need more accurate data as well as the means high resolution data, mostly in case of the ground data or the aerial data. So that means for estimation or measurement purpose, this type of information is much more required. And simultaneously, we'll just consider about the like workstation that have high processing technique, because when the your digital means images will be larger in size, so you need to workstations. There is a very less possibility to use this computer or the some low storage capacity system, because in processing there is a lot of function is going on internet. But if you are doing, it can be done through web-based or the desktop-based, or you can do it through the coding system. There are you can use C++, C, or the Python programming system. So all these things can be used for the processing or the analyzing this information or extracting this information. Now we'll discuss about the different types of means color image. Already yesterday I have shown you that it's the panchromatic image, because there is a one single spectral channel. So whatever the information you are gathering here, there is a one band, so which is ranging from as per your spectral range. It may be the zero means visible, or it may be the high spectral, or it may be the means there's a one spectral width will be there. It's so for example, sometimes you may take it 0.4 to 0.5 or 0.4 to 0.6, whatever it is. Means only one spectral channel or one spectral band or one sensor data that will be provided as a panchromatic image. Sometimes we'll receive the true color image. Obviously, you are very much familiar with the Google Earth image, where you are able to find out the true color image, basically, right? So, however, we are not able to means use this Google Earth image for the digital processing technique, because the Google Earth image, whatever the features are there, it is not downloadable, freely available for the public. You can visualize the data, or you can take a picture of this image, but the pixel properties, like the spectral value, that is one of the main aspect of the for the digital processing technique, that is not available in the publicly for the uh, Google Earth image. So therefore, we need to purchase the different types of satellite data or satellite image or the multispectral image, which is having the geometric as well as the spectral characteristics of the pixel. Like there is one example that I have seen in multispectral image. So based on that, you can process this data in the computer system and extract the information as per your purpose or objectives. Another important characteristics here, there is using this two color system. One is the additive color system, and another is the subtractive analysis of the color. Whereas you can see there is a red, green, and blue. These are the three major color that, and major color in terms of, we can say, is the primary color system, where human can visualize also, or we are able to identify based on these three color. That but sometimes what we'll do, we'll just mix the two color, like red and blue. When you have to mix this red and blue color, you will get a magenta color, right? And then green and blue, when this will be mixed, we'll get the cyan color. And red and yellow, when we will mix, it will red and green, it will provide a yellow color. After all these colors when mixed, this will provide a yellow color. Means there is a red, green, and blue, all 100% saturation. So once the saturation level is 100% of these three colors, we will get the white color. So in that way, the color combination is proposed, and the color combination can be made. So the same concept, the same principle will also apply for the digital image, to get the different color of information system, to get the to identify or to visualize the features of our Earth surface features of the remote sensing data. So there is an example that I have also like a true color image and the false color image. And true color image, so why we're just talking about true color image? True color image, that means say for example vegetation that we are observing as green. In the true color image, we are also able to identify this vegetation as a green. But there is a water body which is blue. In the true color image, you are also able to identify the water bodies as a blue. But sometimes there is a differentiation of the water bodies, or the means different colors of the water bodies, or the vegetations having some different spectral characteristics. Like you can see in this image, some of the vegetation having a dark red, some of the vegetation having the light red, some of the vegetations are very light red. So these spectral properties cannot be identified, or not possible to visualize through our human eye or the true color image. Therefore, we are using the false color image or the standard false color image, because this image will be helpful to identify each and every features based on our spectral properties or the spectral resolution of our Earth surface, to visualize these features, as well as helpful to identify the or estimate the features whatever available on our Earth surface. And then there is a examples of the false color image, that and different types of bands. You can see there is a band 2, band 3, and band 4 that we have described in our spectral resolution class part, where after combining all these three bands, like band 2 here, blue band, band 3 is the green band, and band 4 is the red band, and these three bands combined and make it is the false color image. Now the question is that false color, what is the difference between the false color and the standard false color image? In the false color image, you have to combine different color system or as in remote sensing data, we get the more accurate informations, more exact locations, whatever the features are available, what are the associated features are available. All these things can be possible to identify. So the country, due to the security purpose, what country will do? They will just compose this color image or compose these different types of bands into the multispectral image at different combinations for their security purpose. But there is a one aspect that is considered for the globalized level or for the global estimations, like standard false color image. In standard false color image, what we'll do, the red band is converted into transform into the represent into the near infrared band, green band represent into the red band, and the blue band represent into the green band. This is the universal. Therefore, it is called as the standard false color composition, right? Another important characteristics that I have would like to discuss with you, like general features of the surface appearance. What we'll do, we have to identify all these features, or before designing, or before just creating the sensor or developing the sensor. We need to do some lot of field survey to get the spectral properties, spectral values, as well as the some we need to determine the threshold informations of the spectral reflectance or the electromagnetic spectrum range of the sensor. So, what are the our observations? Based on our observations or field verification during the designing of the sensor, people are trying to get this true color image, and based on this true color image, they will just characterize the informations of the surface features, and identify the same, and extrapolate the same information into the false color image or the sensor, so that once the sensor has been designed and it will used for the to collect the information, so based on their perspective or based on their applications of use or designing, we are able to identify all the features without going into physical contact. That is one of the prime aspect of the remote sensing technique. Suppose for the inaccessible areas, or for the to get the synoptic view of the area, or to extract the information of the large area within a certain period of time, we are able to identify the different types of features or different types of characteristics of the earth surface. That means like tree and grasses, which is in true color image you can see like olive green, whereas in the false color image you may see as a red color. In case of the crop, that a medium to light green color will be shown in the true color image, whereas in the false color image it will be shown at the pink color, pink to red color. And same for the wetland vegetation, there's a dark green to black in color in the true color image, and for the false color it will be dark. So in that way, we just classified all each and every features, and we have need to create a spectral properties, spectral library. So based on that, using the spectral library, we are able to identify or processing this image, and to extract the information for our prospective study, purpose of study. So there are a lot of advantages of the false color image. Like it allows us to visualize the different types of wavelengths that a human eye can doesn't see. That I have already discussed, like thermal properties, or the microwaves, or the infrared, etc. And simultaneously, the near infrared is increase the spectral separation, and also can helpful to identify the different types of features which is not possible through human eye. So the image processing techniques is helpful to interpret or to analyze this data or information. And there are different types of band combinations which also available, so that after combining all these bands, we are able to identify the features, as well as that will be enhances to characterize the features which is available on our Earth surface. So, and the same way, the elevated temperature, the topographical conditions, like different types of forest fires or volcanoes, whatever the activities are going on day by day, or means natural hazards or natural calamities which is going on. So all these things we're able to classify or identify the features. So for example, like climatic pattern or the weather pattern and prediction. Sometimes hopefully people are all are using some Android mobile app or iOS mobile app mobile. So from this mobile you are able to get that next 5 days weather prediction. So this prediction, this information, basically we have will just able to extract to the remote sensing data, and based on this information or the preliminary information, the historical information, or based on its that behavior of the weather characteristics, will be able to predict all this information. So this type of properties or this type of facilities are helpful for this remote sensing data, and by analyzing this processing image processing at the different combinations of the bands of the electromagnetic spectrum. Like band combinations that there is a yesterday I have discussed about the Landsat 7 or Landsat 8 satellite data that I have already for recalling this just make an example that where for the Landsat 7 there is a 8 bands are there. Sorry, 7 bands are there, and for the Landsat 8, there is 11 bands are there. So all these bands are used for the different purpose. Like Landsat 7, you can see the band 1 is the representing the blue band, and the same is the spectral range is also provided here, because spectral range, we know the electron spectrum, the blue spectrum is ranging from 0.45 to 0.50, and simultaneously there is a band 2 is the green band, and this band 3 red, band 4 is the near infrared, band 5 short infrared, band 6 also short infrared, and band 7 band 8 is the phonetic band. So all these bands are available there, and in case of the Landsat 8, there is a they have also used the coastal bands, like Cirrus thermal. There are 2 thermal infrared band. So different types of bands they have used, and they've used the different types of spectral range. Because that is the utility of this spectral regulation of the remote sensing technique, that to identify the each and every features of our Earth surface, we need to identify or we need to delineate its spectral properties, or what is the spectral range the features have been transmitted. Therefore, we'll just means calculate its the minimum spectral range and maximum spectral range, and demarcate the threshold value, so that the sensor will detect these features from the Earth surface, and the same is to be transferred into the labs for the processing techniques. Like I have also given an example, like you can see here, like natural colors for the 432. When you have just used this 4 band, 3 band, and 2 band, you will get the natural color. In case of the agricultural properties or identifying the agricultural land, so you can use the 6, 5, and 2 band combinations. So because at a time, as per our remote sensing software, or the means at a time you can only combine 3 bands. So that it will provide you the spectral properties or the spectral characteristics. Therefore, the combinations is given here, only the combinations of the 3 bands. Maybe in the near future, the technology is going to be developed, and we may use the number of bands at a time, or the combinations will be changed. However, there are another important techniques also available. So, for example, just give an example here. Six type 2 bands. We have just make a combinations. See, there's the vegetations are there. So these vegetations are highly enhanced, means visible clearly rather than the other features. So we can extract these vegetations from this by combining this 6, 5, and 2 bands. In the same way, however, one thing is, you have to keep in mind that these 6, 5, 2 bands always this is for the example of the Landsat data. But when you are going to use the sensor data, it will be vary. So that you need to understand that what exactly the features, or what is the spectral range is used for these combinations. So this spectral range is negative, and you have to change these properties or the bands combinations based on it, the electromagnetic radiation or electromagnetic characteristics. Right? And the same way that you see in the color infrared image, there's the vegetation that showing the red color, where the combinations has been given, it's 5, 4, 3. And this, another important characteristics like land and water bodies that sometimes in the coastal area we are using to we're trying to extract the water bodies, we're trying to extract the land and water the shoreline, etc. So in that case, when we are going to combine these 5, 6, and 4 bands, we'll be able to identify it exactly the extension of the water body and the land. So in that on the continuation of this previous slide, that we are using the different types of ratio and transformation techniques. You know, because sometimes what will happen, there is some error will come. So out of due to some noise, or it may be due to some sensor capacities. So what we'll do in our already discussed earlier also, the spectral properties, some of the features or each features on our earth surface having the minimum reflectance as well as the maximum reflectance in a particular wavelength. If we consider vegetation, we have seen that minimum reflectance is found in the red band and the maximum reflectance is found in the near infrared band. So what we'll do is just make a combinations or make a ratio technique, so that the maximum and minimum, after dividing this maximum and minimum, we'll just get a unique information system or the unique range of the data to enhance or to clarify the informations or to get the more accurate informations of this particular features. So in that case, like in case of again, I'm to example of the landscape data, because why we are using this landscape data, because this data is too much old, that already initiated the landscape program in 1960, and still it is continuing. So there is a lot of information, thousands of information or more than that. So once we are trying to do any research or getting any information or more accurate analysis the information, so there is a possibility or to get these information easily. In the same way, like let's say means TM band 4 and band 3 were giving a ratio technique to distinguish the vegetation, water bodies, and croplands, etc. In the same way, TM 2 by TM 3, which is used for the croplands, barren lands, like you can say this is the wasteland. Uh, as per your purpose of objective, sometimes what people are, would like to identify the wasteland area, what are the extension of the western area of your district or the states or the nation. So after combining or after using this ratio technique, you will be able to identify the wasteland area or the barrenland area, so that you can make a plans to develop this area. We can make an industrial development. You can estimate that what is the extension exactly for development these activities, or to suppose you want the 4-acre area for a development, or for the farm production, or for the industrial production. So where is the 4-acre area is available, which is wasteland basically. So in that case, this technique, this ratio technique, or the remote sensing image processing technique will be helpful to identify these features for our planning purpose or decision making purpose. Next, we will discuss about the image enhancement. Enhance, always people also use this term. That is the increase the, that means it defines the increasing the clarity and contrast of the image. Right now, I have given an example in the below of this page. You can see that there is a two images. One is before the means enhancement, and another is after its enhancement. After enhancing this image, what will happen? It will increase the contrast. It is increase the clarity, that you can you are able to identify the exact water lines, the roots of the vegetations, as well as the different types of features, the shadow, which is not clear in the original image. So therefore, the enhancement technique is required. However, there are number of enhancement techniques available. However, but you can say there is no such a specific technique, specific means theory, you can say, by the remote sensing technique. So when you're going to enhance this data, you just increase its clarity, and increase its gray level of these features. So this gray level may be done through the contrast enhancement technique by defining into different contrast, defining the different types of lightness, or stretching the means data into from the minimum to maximum. And then there are some special features are available, like filtering, its detection, or the Fourier analysis of, and there are some multi-image manipulation, like band rationing that we have already discussed earlier. There are principal component analysis, whereas we are using the number of bands, but it's without increasing its means originality of the data, and there is some canonical component analysis, like we are using this spectral band into different spectral range or different angle, or putting the informations into different axes, like x and y axis and z axis. So in that way we just do a enhancement technique. So these enhancement techniques can be done in a two way. One is known as the point operation technique, and another one is known as the local operation technique. So in case of the point operation, you can see, if we say, so for example, these are points, right? Are you able to visualize these features? So in point operations techniques, say for example, there is another features that I will classify it like, right. No? Give me an example. Right. So this is the point operation. In case of the point operation, what will happen? It will just means enhance the features in and around the points. But in case of the local operation, what will do? It will consider all these total blocks or its neighborhood areas to enhance these features, or in increasing the contrast and clarity of the features in the image. So this is the basically the basic difference between the means point operation and the local operation of the image enhancement techniques. So there is some example that I have put here, like contrast enhancement. Like you can see that the original image we have received from the sensor, or after means converting into the signals into the image. This is the original image. There is a means contrast is very low. So there is a some of the features are available there, like vegetations and some settlements areas, or the built-up area, as well as these are the area like some development activities is going on. But due to low contrast, sometimes if you are not a remote sensing expert, or you don't have means too much knowledge about these areas, so it's become difficult to identify exactly the what features and the extension is. So that by increasing the contrast of these features, we are able to identify, or increasing the means gray level, or defining this means stretching this data from the minimum to maximum extension of the brightness value, where we can classify, or we can able to extract the spectral features of the spectral properties of this particular area. And then spatial filtering, or convolution, and what will happen, sometimes some of the features are having some higher reflectance, and some of the features having some lower reflectance. So for example, you can see in the lighter area, or the sandy area, or the stone area, during the sun, when the sun shines, or the illuminations of the depending upon the illumination of the sunshine, it will warm up very quickly, as well as it will also going to be cold very quickly. So in that way, there is a much more spectral reflectance, or the thermal properties of these features is much more. So in that case, we are using the high pass filter, because what the sensor will do, in the sensor we are using the different types of filter, which filters only accept the spectral range and the the wavelength of the particular electric spectrum of the particular feature. So in filtering, based on the spectral properties, what we have done through our field survey or the threshold value, whatever we have defined by to identify these features in our ground. So the same principle or the same design has to be transferred to the sensor, so that sensor will accept these features through its low filtering technique. Either it will be high pass or low pass. In case of the low pass filter, it will pass the low wavelength range, but it means do not pass the high wavelength of the wavelength range of this particular sensor or particular detector. And in case of the high pass filter, what you will do, you will pass the higher wavelength but block the lower wavelength. So in that way, the sensors are able to detect the features or captures the features informations based on the spectral properties or the wavelength properties of the electron spectrum. In the same way, in edge enhancement, where it is also a conventional technique, sometimes what will happen, due to this means clarity or means contrast of the features, we are not able to identify that the linear features, or sometimes some artificial features are available on the ground, which is not possible to identify through this means raw image data. So in case of the edge enhancement, it will what will do, by using this filtering technique, it will define the exact edge. Sometimes but in geological applications, would like to identify the lineament. If you are also means engineering project, you would like to find out the different type of geological structure. So this geological structure or those means traits of the features, that can be possible to identify through this edge enhancement technique. And another important enhancement technique like histogram equalization. In histogram equalization, what will do that you can see that some of the features, that the spectral properties of the features that is accumulated, or the histogram is much more longer, higher, and in some of the areas there is no any histogram has been found. So that in histogram equalization, what we'll do, we'll just classify it, or we'll just in the divided the spectral properties or the number of pixels into the different histogram or different spectral range, so that it will enhance the image or increasing the contrast. So for example, I given in the next slide, you can see that there are different types of histograms that I have drawn. One is the symmetric, one is the skewed, there is a bimodal, there is some multimodal, different types of histograms are there. That means it is indicating that the features are only accumulated mostly in the lower part of the spectral range. Here, the intermediate part between the minimum and maximum value, there is a no pixel, or the number of pixel is very less. So once you need to identify the what is the situation, or what is the exactly the features are available on the ground, and if this is not correct, then we need to do some histogram equalization, or means for enhancing the image, and to for the segmentation of the means histogram into different characteristics, or creating into the symmetrical form or the normal distribution, so that the contrast and clarity of the image will be increased, and it will be visible, or people can able to identify these features more clearly, or without any means of any error, or can distributed the spectral properties with the inter, or the lightness, or the brightness, or the contrast in the inter image, inter part of the image. And then another important characteristics is the density slicing. That what we'll do in density slicing, we'll just classify the pixel properties, or the classify the digital numbers of the pixels into the means 2-3 groups, or the number of groups based on our uses. Like our in our Earth surface, there are thousands of features available. So thousands features having some thousand properties. Like if you can consider the vegetation, within the vegetation there are a number of categories are there that we have already discussed in our spectral properties slide. And the same for the water bodies, there is a variations of the water bodies. So once we need to identify only the water bodies or the vegetation or the settlement area or the build-up area. In case of the build-up area, you can see that due to the difference of color variations of the buildings, the spectral properties is also changed. So we need to identify the each and every building for our project purpose, for example. So in that case, we have to just use this the entire range into the particular class or particular group. So in that way, we have to classify the density into different categories. Let's say that there is an example of the features of the black and white pictures of the panchromatic image, where we have classified into the number of just 3-4 classes that is like temperature variations we have given. So from here, you are not able to identify the exact temperature, or you need to identify each and each pixel by getting the spectral properties or the spectral value or the pixel value. But once you differentiate into a different class, so you just call it that less than 28 degree, 28 to 29 degree, or 29 to 30 degree. So it has become visible, or people can actually understand that what exactly the distribution or the temperature range of this particular area. So this is the funda of the density slicing of this enhancement technique. Now I'm talking about the image rectification technique, which is one of the most important aspect of the digital image processing. You know, sometimes we don't have the coordinate system, or if you do not know about the exact geographic location, so it's become difficult to identify what exactly the features are there, and how it will be compared with the real world coordinate system. So it is the process that we can say georeferencing, where we are putting the coordinate system, like in our earth surface coordinate system. We'll use basically the spherical coordinate system, or the means there's a rectangular coordinate system, and or the planar coordinate system. And the same way, there is a number of projection techniques are also available, like there is a so, conical projection system, there's a polar zenithal projection system, there's a stereographic projection system, there's a cylindrical projection system, there's a marketed projection system. Number of projection systems are available. So we need to use this projection system or the coordinate system based on our purpose, or the when you're going to do any project or any design. So sometimes the stakeholder defined that we need this information into this projection system, or into this coordinate system. So based on that, we'll do the putting our coordinates or the coordinate value that may be collected from the ground, or the in case of the sometimes for the preliminary analysis, we may use the survey topographical sheets, because survey topographical sheets having the only source of our old information system, having the different type of coordinate system, or the coordinate value, or the latitude and longitude value. So using this latitude and longitude value, the same has to be transformed to the raw image data, and same to be compare with the real world features to extract the information, so identify the exact locations of the features on our earth surface. So this projection system, another important characteristics why it is required, because this geometric correction, or the sometimes there is a differentiation, different variations in the sensors are found. That is maybe due to the altitude characteristics, or the velocity of the aircraft, or the spacecraft, or sometimes there are some atmospheric reflection which occurred. Sometimes earth curvature is another important characteristics, because at the geographical latitude, or the vertical angle, you may get the more accurate information. Once the curvature will be increased, or the axis of the camera will be deviated from its vertical line, then again there is a destruction it's occurred. It may be the distortion of the scale, it may be distortion of the angle of the features may be found. And simultaneously, the relief characteristics, in the plain area, you may not get too much distortion. But in case of the hilly area or the mountain area, it's become difficult to collect the information, or sometimes most of the engineering purpose we need to develop, or lot of engineering works is going on in the mountain area. So on that case, if the projection or the your means estimations is not too much accurate, there is a lot of problem will occur, or a lot of challenges the engineer will face. So in that case, the proper correction or the proper rectifications is very much important. That will eliminate the different types of geometric errors or different types of distortion, as well as the transform the image into the particular coordinate system, and to accurately measurement of the particular features of this area. So there is an example that I have seen you. I have shown you that some of the geometric errors, like changing of the flight range. So pixel size will vary. Some of the means due to the difference of the direction of the movement. So you can see the image. We need the image like in that way, but its angle has been changed. So this type of error is occurred in our remote sensing system, that we need to do the rectification technique to correct this of its proper position on the location. So in image processing technique, there are in rectification there are two aspects are there. One is known as the spatial interpolation, and another is known as the intensity interpolation. In spatial interpolation, what we do is just provide geographic coordinate, exact locations of the features. But in case of the intensity interpolations, once you are deviating from your exact location, so your intensity or the value of the spectral means pixel will be changed. So in that case, once you are doing the exact geometric correction or the georeferencing or rectification, whatever you want to say, that it will also accurate your DN value, that means the digital number value, as well as the pixel value of the corresponding area of this particular features. So therefore, I have just put an example like the pixel, that is the ground control points, that the locations of the features of the Earth surface that we have collected from the field, and same has to be transferred to the satellite data for its position, or to identify its real world coordinate system. So ground control points basically is the points that is collected from the field to different types of field survey and the ground ground platform that we have already discussed with you earlier, like digital DGPS survey or GPS survey, etc. So and these points will be helpful to rectify this data or rectify the image. So what spatial interpolation will do? It's that the example here I have put it. That exact locations, the features of the raw image, you are just getting here. The location is there, but when you are going to transform the image, but its exact locations on the real world features is correct exactly in this position. So once you are trying to identify these features, its exact locations, and incorporate into the this position, so that your location will be changed, your projections will be defined, and you can easily estimate the scale. You can easily accurately estimate the area of the image. So this information is also means there are certain features are there. So once we'll do some practical classes or practical some work. So on that time I can show you what are the features, what is the process are there, and in image processing software, the process need to be followed, and how to define the GCP. And another important parameter when we do the projection system, there is a order of transformation there. Order of transformation that will define that how many GCPs is required to rectify the image. Sometimes you need the first order transformation. So in case of the first order transformation, you need minimum 3 GCP. So what will the 3 GCP will do? It will basically create an angle. Once you get the 3 points of a particular area, that hope you are already familiar with this technology and techniques, that you just create a triangle, right? Once you are getting a triangle or the 3 points, you are able to identify its angle, its length, and based on that, you just make a measurement, and you can estimate the particular locations of these features. So in the same way, in a principle will be used for the spatial interpolation technique, and here I have put the how many order of transformation is we are considering order of transformation and number of GCP, and how to calculate this GCP, that t plus 1 and into t plus 2 divided by 2. T plus 1 here the t is the transformations and which transformations we get, and 1 and 2 is the values of the GCP, so that you can calculate the GCP number based on your rectification technique or the processing technique. And another important characteristics of this spatial interpolation or means accumulating the GCP is that, like in the plain area, we may use the minimum number of GCP. Minimum in the sense of minimum 3 GCP is required. That is your threshold value. You cannot go beyond that. Means 3 GCP is must. After that, once the elevations or undulations will be increased, you have to increase your GCP value so that you may get the more accurate information or more accurate corrections of the image data. In the same way, the intensity interpolations has been carried out, that I've told you earlier. Sometimes due to some sensor error, you may get this type of stripping of the data, and sometimes the error will come, like banding, some black spot will become, or some detector will be damaged, or within the 100 of detectors, one detector may not work. So in that case, how to correct this data, or how to rectify this information. So this rectification can be done in the three ways. One is the nearest neighborhood, another is known as the bilinear interpolations, and third one is not known as the cubic convolution. In nearest neighborhood, what we'll do is just transfer this image, that it's a neighboring pixel, the digital number or the pixel value of the neighboring pixel, we have to transfer into the next column or the next row value, so that we may consider that the associated features or the associated spectral properties almost means nearer to these features, and based on the spectral properties, we have to identify, or we have to recognize these features of our Earth surface. However, there are some it is a computational simplicity having the advantage, but it there are some of the features, like when we are considering the 30 meter by 30 meter pixel, you can understand that within this 30 meter there are a number of buildings are there. So in case of the high resolution, we may not get the exact information of this particular features, or maybe there are some misinterpretation. That however, if we consider for the larger area, larger prospect, larger region, so in that case, definitely it is 100% accuracy will be there. In case of the bilinear interpolation, what we'll do in bilinear convolution, it will consider the nearest 4 neighboring pixels. Suppose this is the central pixel, and you can consider the 4 neighboring pixel of this digital number value, and we will just convert its pixel value, taking an average value, and it converted into the pixel of this particular line or particular band, or sorry, not band, we have basically strip or row number or column number, so that the same information has been transferred to the next column where the detector is not working, or the sometimes because once you have to launch your satellite in the 700 kilometer or 800 kilometer, it's become difficult to calibrate your sensor characteristics, or changing of the sensor. So in that case, this is the duplicate way, or you can see the alternative way to getting the accurate information of this particular time without hampering this information capacity of the satellite characteristics, or by acquiring this information to continue this process or life cycle of this satellite. And the other important characteristic is the cubic convolution. You can see that there are in the Landsat ATM sensor, this problem has come, and if people are familiar with this Landsat ATM sensor, and if anyone can use this Landsat ATM sensor, they may get this type of image, and the similar image that I have already shown you. This type of image rightly collecting by the Landsat ATM sensor, because some of the detector is not working due to some functional problem. So in that case, but you need this information, or you collect this information of this particular sensor due to some some data are not visible or our satellite are not available, so that we need to use this satellite data. So in that case, what we'll do, we'll do the different types of intensity interpolation technique, like in neighborhood or bilinear or cubic convolution. In cubic convolution, what we'll do, we'll just take 16 number of pixel values of the neighboring pixel value. See, this is the pixel numbers, and we are considering the 16 neighboring pixel, and accumulate the information and transferring the information into the rectified image, so that it will means smoother of appearing and provide the slightly sharper image, so that easily helpful to recognize and classify the features of this particular area. However, this performed after the image classification procedure, and the digital numbers, it's sometimes long processing technique is when time is required to classify the image. This is the another important example, like I'm sharing that ADAS imaging. This is the one of the important image processing software in the remote sensing field. However, there are a number of softwares are available. So hopefully, this is the first software has been developed for the remote sensing data analyzing for the image processing technique. So these are some techniques that I have already put that how to means do the rectifications, the steps has been given. So I am just sharing the slides and all this means information, so that you can go through the steps, and you can able to classify or rectify this remote sensing data or the raw image data by following this step in the ADAS imaging software. Our a practical session we'll discuss, and we may use this step further. So this is the all about today's lecture. Thank you all of you. Thank you for your kind attention. So if you have any query, you may please ask, or you may put in the chat box. Once I'm asking what is the GIS data? GIS, there are some questions that Vikas is asking, and I'm just GIS. GIS, that means Geographic Information System. So GIS data, there is two types of data that next class, next lecture we'll discuss about the GIS. That we use the spatial data and the attribute data. Where the spatial data that allow you to means getting informations of the exact locations or exact means like real world features, and attribute data. So for example, I'm sitting here or you are sitting there. What is your exact locations? That is latitude, longitude. That is your spatial data. And where you are located, your buildings location, how far away from the roads, what are the associated features are available, how many people are there in your buildings, family, etc. All these are coming under the attribute data. So in GIS data, there are a number of this special data that it may be the remote sensing data, it may be the different ground data, right? So this is called the GIS data. So and another important another question you have asked me, that aerial photo. Aerial photo, that previous class we have studied on the previous lecture. We've used the different types of platform, space-bound platform, aerial platform, or the ground-based platform. So when you are using this aeroplane or drone, we just fixed camera within these aeroplanes and drone, and this will take a picture, and same pictures will provide to us. So like satellite image, you will get the aerial image. It will much more high resolution than the satellite image, because satellite image, what we are taking, that is about 700 kilometers or 800 kilometers from the Earth surface. But in case of the aerial image, you are taking it like 7 to 8 kilometers. In case of drone, you are using 400 to 600 meters from the Earth surface. So all these are comes and means aerial photo is just based on the aerial means aeroplane. Using this aeroplanes, we are collecting the information. Next, someone is asking, because again asking about the ADAS. ADAS is a software name that is ADAS imaging, that is used for the image processing purpose, like different types of image processing, like enhancement, rectification. Yeah, because the satellite image, whatever the image you will get from the satellite data or the raw image, that is only possible when you have there is a capacity of the remote sensing analytical capacity. So there are each and every software means don't have such a capacity. So there are specific remote sensing and GIS software that you need to consider for this type of analysis, or for this type of means correcting informations or using this process of this remote sensing or GIS. PDF, because already I have shared with Dr. Bijendra. I hope he will share with you. If you have any other query, you may please ask me, or otherwise I will hand over to Dr. Bijendra for.
Yes, sir. Thank you so much, sir, for your today's session, and it was very fruitful to the students, and you have answered all the questions to our participants. Thank you so much, sir, for the today's session. We will meet tomorrow for the last day in the same time with the same link. So thank you, participant also, and thank you, student coordinator, who are supporting this webinar.
Thank you so much. Thank you all of you for your kind attention and stay with me. And thank you once again. And definitely tomorrow we'll meet. Thank you.